So we are the team and we're going to present you the problem 3. Each time your heart beats, your blood pressure increases, then decreases as the heart rests between beats. A certain person's blood pressure is modeled by the function PT equals 115 plus 25 sine of 160 times pi times t.
Well, I'm going to solve the point A, that is, find the amplitude, period, and frequency of P. First, the amplitude. We know that we have a sine equation, so we know that the amplitude is 25. Let me write it. Amplitude equals to 25. Then the period here, we know that to find the period, we need to divide 2 pi over k. K in this case is 160 pi, so we need to divide it, and we have that the period is 1 over 80. Let me write it. 1 over 80. And then the frequency. The frequency, we need to make the division 1 over the period. In this case, is 1 over 1 over 80. So we need to do the tortilla law, and the result is 80. So that's it, and this was all of the point A.
Okay, so now we are going to start graphing this function, but first we need to explain some points that were added. We have now B and C. B, as you guys know, we got the period, so 160 pi plus t was read away, and t was left only in the parentheses, so there was no phase shift. So that's why B is equal to 0. And also we have that C is equal to 115. So here in the function, there is a law that says that in this position, this will equal to 115. So that's why here is 115, and it equals to the new x axis. So now we are going to start graphing. So as we got the new x-axis, this we need to count 115, and it will be here. So we have now this C. Now what we need to do is use the amplitude. We know that it is 25, so it will be 25 up and 25 down. This will be like this: 90 down and 140 up. So now we need to divide our period in 4 because we are going to start graphing, and we know that our period is 1 over 80. So if we divide that over 40, it will equal to 1 over 320. And we need to start putting the other terms. So okay, we start. Here we have our first point, second, third, and fourth. So we do our line, also here, and also here. So our first number is 1 over 320, and then we have 1 over 160, then 3 over 320, and finally 1 over 80. So the period was divided over 4, and this is our result. And there wasn't a phase shift, so that's why it remains like that. And now we need to start graphing the weight, and it will be like this. So as we know, the weight is positive, so we know that it begins here, it goes here, 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 and here. So now that we have our points, we just need to draw it. So, like this is our sinc function positive with all our variables, and it will be like that. Yes.
So now we are going to answer the point C, that is, if a person is exercising, his or her heart beats faster. How does this affect the period and the frequency of P? Well, the answer will be if the heart beats faster, then the period will decrease, making as it is faster, but at the same time the frequency will increase proportionally to the decrease of the period.
So we learned with this problem how to apply a sine function, which is graph, into a normal situation. And in this case, it is the heartbeat. And it's a great example because as the heart expands, the pressure will increase, shown here by the graph. Then, as it expands, the pressure of the bloodstream will decrease. And also, we learn as the frequency of the graph increases, the period is going to decrease, making the beats more often. And that's it. Thank you.